Welcome to the next video in the Discrete Mathematics video series, and we are going to solve this exercise from last time where we determine the perhaps counterintuitive truth values of conditional propositions. So this one, if 0 equals 1 then the sun is cold, naturally you would think that that is a false sentence. Primarily just because these two things seem to have nothing to do with each other, so why should that be a true sentence? But notice that we are working with a truth functional conditional operator, right? So all it looks at is the truth values, not whether those particular sentences are talking about related concepts, which maybe is a deficiency, right? And, certainly when it comes to scientific reasoning about causation and who knows what else, that maybe really is a deficiency, but, since all we're really, mathematically, we're generally just interested in, the truth of sentences. And so in a certain way, this is maybe a conditional that is built for mathematics, but maybe not the most appropriate for other settings. So in any case, so mathematically, we would just say that this is some false sentence, arrow, true sentence. Sorry, what am I thinking? False sentence. But the important thing is to note that in the conditional truth table where you have false, false, it is true there. And so therefore, nope, this is a true sentence when working with the, this is, by the way, the version of the conditional where we regard it as merely reading truth values. This is called the material conditional. It has a sort of special name. And so in mathematics, we use the material conditional because we're only interested in the truth values of these various sentences. And so that's the one that we use. It's very simple to analyze. And so whenever we're saying, if a triangle has 3 angles or a polynomial, or if a polygon has 3 angles, then it has 3 sides. For instance, to give you a mathematical conditional sentence, when we say that, we are using the material conditional. We're only interested in the truth values of the component sentences and how they build up to the truth value of the final sentence. So this material conditional is used in mathematics, but maybe not in the sciences that are more interested in related causal relations and things like that. So anyway, okay, let's move on. Here, this is false, false, and so yet again, this is a true sentence for the same reason as above. This is true, false, and therefore this one actually is false, that, matching the reason, the answer that you might give intuitively, but maybe not for the reason, right? Because here the reason is merely because of the associated truth values, not because they are unrelated sentences. So anyway. And then here, this is true, true, and therefore it is a true sentence. But again, and that also maybe is not what you would expect if you were just looking at the sentence, because again, you would think that these do not necessarily have anything to do with each other, and yet mathematically we regard them this as a true sentence. Okay, so there is all the solutions that we've just talked through. Okay, now let's note it. Really, we have enough operators to talk about now that we can start noticing some properties that certain operators have which others don't. So the other operators, the conjunction, the disjunction, the XOR, those are all what are called commutative operators. And what that means, by the way, is that, whenever you write P conjunction Q, it is equivalent to Q conjunction P. So the equivalence, right, just swapping things around is equivalent. And that means that they always have the same truth value. So if you wrote the truth table for this sentence, you would get the same truth table as for, that sentence. And so that's what equivalence means. So anyway, right, but you can kind of just think that, well, they're basically saying the same thing. And likewise for disjunction and for XOR, if you were to write down, for instance, P or Q, it would be the same. It would be equivalent to Q or P. So that, right, to summarize that, we just say that those are commutative operators. And so then, what we should maybe ask are there any non-commutative operators? In particular, what about the conditional? And yes, it is very, very important to realize that the conditional operator is not commutative, that if P then Q results in something different than what if Q then P results in. You can do the truth table and see the difference directly. But what I want to talk about is although they are different, they are clearly somewhat important to each other, especially when we use these in sort of applications that if P then Q, whenever if P then Q is true, we are often also interested in the question of whether the converse, right? So when we switch them around, we call that the converse. And whenever we know that one implication holds, it's often at least interesting to question whether the converse is also true. Now, that's not the only way to get a related conditional proposition. There's also the thing that we call the inverse, which comes not from flipping them around, but by negating each. And we might wonder whether or not, if you have a conditional, right, if P then Q, is it related in some, right, is it equivalent to the inverse? Is it equivalent to when you negate each one, right? Does something like a sort of double negation go on where because you negated each one, then maybe now it goes back to being equivalent to the original sentence? Well, it turns out the answer is no, that does not happen. But what it does turn out is that these two, right, the converse and the inverse, are actually equivalent to each other. And that's worth knowing. I mean, one thing, when you know that some two things are equivalent to each other, what that kind of means is that if you ever needed to prove a sentence like this, and we will often need to prove sentences based on what their form is, right? Basically, we will need to prove sentences, and the proof technique that we use is often determined by which operator makes the sentence, right? What kind of a sentence it is often determines how we prove the sentence. And so if you are ever tasked with proving a sentence of the form if Q then P, it's really worth knowing that this, right, a sentence of this form, negation P, arrow, negation Q, is equivalent. Because what that tells you is that if this is hard to prove, you could instead prove this, right? So that's kind of, one of the sort of cache values of knowing that some two things are equivalent is that it gives you the permission to say, well, look, if this is hard, I can prove the other one instead because they're equivalent. And vice versa, right? If you were ever asked to prove this, then you can always instead prove that if it's easier. So it's, that's just kind of a nice, that's maybe an argument for why you should care about whether two sentence forms are equivalent, is because when you get around to proving sentences based on their forms, then you can exchange one form for another, and sometimes that makes the proof easier. Okay, but anyway, getting back to the main point is just to define these terms. So the converse we've already said is that, the inverse we've said is that, and then, and I should have put this in bold, so my apologies, you should imagine this bolded, but the contrapositive is that right there. And notice that the contrapositive is really the same thing as if you did the inverse and then the converse, or the other way around, it doesn't matter. But this is kind of like doing both, right? This is like the inverse of the converse, or it is the converse of the inverse. You'd get the same thing either way. But then the important thing to know about the contrapositive is that the contrapositive actually is equivalent to the original if P then Q. So these are equivalent, right? So the converse is equivalent to the inverse, and also the original is equivalent to the contrapositive. So a lot to remember. Maybe make flashcards or something and try to remember these definitions and so on. And make sure that you know which of them is equivalent to the others, because that is extremely useful, especially when we get into proofs. Okay, now I wanted, and again, I'm introducing a lot of this not in the order that the textbook introduces it, I think, if I recall correctly. But I wanted to talk about all of these things because the textbook does talk about all of the various English structures constructions that would get you a conditional sentence. And one of them in particular is the only if construction in English that gets you a conditional, but it often is not the direction of the conditional, right? If you think that this conditional is in one direction and this conditional is in the opposite direction, then, this one is what you get from saying if P then Q. So that's one direction. This is if Q then P. So they're in a sense in opposite directions. And so what do you get if you said P only if Q? And I think a lot of people, myself included, generally think that the placement of the word if is really the indicator of the antecedent. Oh, I should have included that whole conversation in these notes. So I should do that now. Let me tell you right now that the thing that goes to the left of the arrow, the thing that goes to the left of the arrow is called the antecedent. I should have put that in the notes, antecedent. And the thing that goes after this thing here, that is called the consequent. It's right. It's valuable just to have names for these things because it helps us to talk about them. By the way, I'm really realizing a number of things I wish I had put in these notes, but I'll just put them in right now, is, what do we have for the names of the components in a conjunction? Well, we call each one a conjunct, right? We call this one a conjunct and this one a conjunct. And the reason why we don't distinguish between them is because of the commutative property, right? It doesn't matter which one goes to the left and which one goes to the right. It's they kind of play an the same sort of role in the conjunction. So we can call just one that, if we wanted to, we could talk about the left conjunct and the right conjunct. Over here with disjunction, if we had, for instance, P or Q, we call each of these a disjunct. And again, we don't distinguish between them by giving them separate names. We could always talk about the left disjunct and the right disjunct. But again, it's a commutative operator, and so the sidedness doesn't really matter. But we give them different names in the conditional because the different places really mean something different. And so anyway, so the thing to the left of the arrow is the antecedent. The thing to the right of the arrow is the consequent. And so the question that sent me down all of these considerations is when you say P only if Q, I think when I try to sort of analyze that, my instinct says that the if phrase tells me where the antecedent is, right? Certainly that works if you say if Q then P, the if is telling you that the Q is the antecedent, and if you said if P then Q, then the if is again telling you the location of the antecedent. But it turns out that when the word only occurs, it flips the direction of the conditional. That is the important lesson here. And so P only if Q is actually the same thing as if P then Q, which is very surprising. And so let me try to give you an example that maybe makes this make a little more sense than what your instincts might tell you. So let's imagine a scenario in which there is a bridge that leads to a kingdom and you need to enter the kingdom. Once you're in the kingdom, you might save the princess or save your friend, but you only have time to do one of these. Okay, but the bridge is guarded by a knight, and you can only enter the kingdom if you defeat the knight. And so an apt sentence to say is you will save the princess only if you defeat the knight. I think that is intuitively clear, right? Bridge, I'm not going to even try. Oh, man, that looks like a frowny face. Okay, maybe I should do a little more to draw you, the great knight with a sword. Okay, but I should also not get carried away. And then there is, the other who is, just as intimidating, but I don't know, has a vertical line for some reason. And what is that, a jousting stick? I don't know. Okay, so there's the bridge into the kingdom, guarded, right? You have to get past the knight, but once you're over, in the kingdom, then, there is the, princess in a tower, and then there's also your friend in a squalid jail cell, holding on to the bars. Okay. Anyway, so you will save the princess only if you defeat the knight. Yes, I think that makes very compelling sense, and therefore we should accept that. But if we accept that, if we think that that is true, but we also think that the if just simply tells you the location of the antecedent, that means that if you defeat the knight, then you save the princess? That doesn't follow, because you might save your friend. So the first sentence is clearly true. The second sentence is clearly false. They must not mean the same thing. So there's my argument. Whereas the other way around, right? By the way, let's also think of it the other way around. If you if you save the princess, then I have to conjugate this for time, defeated, previous to that moment, the knight, but you get the idea. And so that sentence is true, right? So this sentence, given the description of the scenario, is true. This sentence is false. It must not mean the same thing, but this sentence is true. And so since maybe we think it has to be some kind of a conditional, it's a pretty good evidence that these conditionals say the same thing. So again, right, the point of this long exposition is that if tells you, right, whatever comes near the if, usually right after the if, tells you the location of the antecedent unless the word only appears, in which case it flips the direction of the conditional. So that's the important lesson here. If tells you the antecedent, except when the word only appears, then the position is flipped. Okay, there's just a lot of the script for what I've already explained on the earlier page. This is the rule that the occurrence of the word only in a conditional sentence flips the direction. And so, okay, let's move on. All of this helps us to understand a phrase of the form P if and only if Q. P if Q means, right, so the if part corresponds to if Q then P, right? Because the if for that is talking about the P, and for that part of the sentence, we don't have the word only, so we're saying if Q then P. So that's the if part. And, okay, we know that we are conjoining that with the only if part, and that is basically the same as saying P only if Q, which we have now learned means if P then Q. So, effectively, P if and only if Q means this, right? This is the same thing as P if and only if Q. To shorten it, because that comes up so often, we call this a biconditional, and we write it with the left-right arrow. And this will be true when P and Q share the same truth value, and otherwise it is false. You can actually confirm this, right? I don't even really have to tell you this, although it can be useful to see that. But really, you could have just worked it out simply by producing the truth table for this right here. So if you produce the truth table, you should see that what I describe here is correct. Let's produce the truth table for this proposition, and I'll reveal it in the next video.